Next, we are going to discuss the question number 4. A sinusoidal voltage V is equal to 200 sine 314t is applied to a resistor of 10 ohms. So calculate the RMS value of voltage. First write what is given in the question. So given V is equal to V naught sine 314 into T, and resistance R value is given like 10 ohms. So only these three things, two things are given. So first we have to find RMS value of voltage. That means effective value of EMF. So you can write your EV, or what else can we write? ERMS. So ERMS value is equal to, what is the formula? E naught by root 2. So what is E naught here? So you can see that E naught or V naught, whatever you take that. So V naught will be 200. So 200 by root 2. So this value will be like 141.44 volts. Now second thing, they are asking to find the IRMS current. RMS current means effective current or IRMS current, which is equal to, yeah, what is the relation between that EMF and the current I? So definitely it will be like in terms of ERMS by what is the resistance is given 10 ohms, like it is like I is equal to V by R, that formula. V is equal to IR, so I is equal to V by R. So already we got ERMS value in the previous subdivision. So 141.44 divided by what is the R value is given 10. So one decimal point it moves. So 14.144 amperes. So this is the second part. Now in the third part, they're asking what is the power dissipated as heat. So what is the power formula? Power is VI. So here ERMS into IRMS current. So you can substitute the values. What is the ERMS current you got? Voltage you got 141.44 into what is the current we got? 14.144. Now multiply this in calculator, and what is the answer you got for power? So 2000.5 watts. So this is the power dissipated as a heat. Next, question 5. In the LCR circuit, the resistance is given 200 ohms and the voltage and frequency of the main supply is 200 volts and 50 hertz respectively. On taking out the capacitance from the circuit, the capacitance from the current lags behind the voltage by 45 degrees. On taking out the inductor from the circuit, the currents lead the voltage by 45 degrees. So calculate the power dissipated in the LCR circuit. So first write what is given in this question. So resistance is given, so 200 ohms, and what is the voltage is given? 200 volts. And what is the frequency of the alternating current is given? 50 hertz. And what is the angle is given? Phase angle 45 degrees. So when LCR circuit in the resonance, what is the condition? At resonance, so omega L will be equal to 1 by omega C. So this is the resonance condition, right? So now we can see that now what is the power dissipated formula? V into I. So that is V into I can be written as like V square by R, since current I is equal to V by R. So in place of I, if you substitute I is equal to V by R, so you will get V square by R. I mean this is V by R. So V into V will be V square by R. So this is the power. So what is the voltage given? 200. So therefore it is 200 square by what is the resistance given? Like 200. So what is the answer? So 200 watts. This is the answer for this question number 5. Next, question number 6. So what is the turns ratio when Ns by Np in an ideal transformer which increases AC voltage from 220 volts to 3300 volts. What is the formula for turns ratio? Number of turns in the secondary coil by number of turns in the primary coil is equal to EMF in the secondary coil by EMF in the primary coil. So this is the actual. So what is the EMF secondary coil? So this one is EMF in the secondary coil. This will be the EMF in the primary coil. So therefore directly you can use that relation. So 33,000 by 220. So simplify and use the calculator, you get 150. So NS by NP, the ratio is 150 by 1. So this is the ratio that they ask. So this formula is also very important based on the turns ratio. I hope you understand.